Good morning, and today we are going to start a new topic, and that topic is the straight line. And to begin with, we will just simply be continuing with some of the knowledge that we should already have from National 5. So we're going to have another little look at the gradient, and again a lot of this is from National 5. We should know this from National 5, that the gradient of a line AB is y2 minus y1 over x2 minus x1. And the y2 minus y1 is just the vertical height, the difference between the two y parts of the coordinate. And the x2 minus x1 is the horizontal distance across the way, the difference between the two x values within the coordinates. Lines that slope up the way from left to right, as you can see from that line, have a positive gradient, and lines that slope down the way from left to right have a negative gradient. A horizontal line, which is a line that is parallel to the x-axis, has a zero gradient. Now, if you have a line that is parallel to the x-axis, then it's going to be crossing the y-axis at a certain number. So the number that it crosses the y-axis at is what you use to get the equation of that line. So the equation of a horizontal line would be y equals something. So if it crossed the y-axis at 3, then the equation of the line would simply be y equals 3. For a vertical line goes up and down the way. That would be parallel to the y-axis. We see that has an undefined gradient. Now that line would be crossing the x-axis at a particular number. And whichever number it crosses the x-axis at, that is part of the equation. So it's x equals 3 or x equals whichever number the vertical line crosses the x-axis at. Any two parallel lines or more parallel lines have equal gradient. If the lines are parallel, go in the same direction, the gradients are equal. Okay, now here is something new. This is a higher content that we're going to look at. So the gradient of a line is the same as the tangent of the angle. We know the tangent of the angle is tan of the angle. Now we tend to use a lot of Greek letters when we're doing higher. So that's just a Greek letter theta, tan theta. So the gradient of the line is the same as the tan of the angle that it makes with the positive direction of the x-axis. Now what I mean by that is that to find the gradient of this line here, it's going to be exactly the same as the tan of this angle. Okay? And until you learn in the higher course how to do the tan of an angle without a calculator, you would just stick that into the calculator if you're given that angle. Now this part here, it makes with the positive direction of the x-axis. This is the positive direction. This is the negative direction. So it means on the right hand side of the line, it's got to be that angle there, between the line and the positive direction on the right hand side of the line. So if you happen to be given this angle here, that's not the angle you would use. It has to be this one here. That's all that means. Okay, so let me just prove this to you here. We know that tan from SOHCAHTOA is opposite over adjacent. Okay, so if we look at this line here, we make up a little right angled triangle, then tan is opposite over adjacent. But we also know that the gradient is vertical over horizontal. And vertical over horizontal are these two ones here. So if tan is opposite over adjacent and gradient is vertical over horizontal, then that means that the gradient and the tan of the angle are exactly the same. And that's the proof. Okay. Example 1. Find the angle that the line joining the point P14 and Q310 makes with the positive direction of the x-axis. Okay, so you need to have that as a trigger and think, I know that the tan of the angle is equal to the gradient. That has to be something that you now have to be very aware of for the higher course. So the tan of the angle is equal to the gradient. So for me to be able to find this angle, I'm going to first of all have to find the gradient. So I'm going to use my normal formula to find the gradient, y2 minus y1 over x2 minus x1. Okay, and then put the numbers in the correct place. Okay, so we've got 10 minus 4 over 3 minus 1. 10 minus 4 is 6. 3 minus 1 is 2. That simplifies to 3. So that means that the gradient of this line is 3. So now we connect it together with the fact that the gradient is equal to the tan of the angle. So the gradient is equal to the tan of the angle. Tan theta is equal to 3. And theta will be simply inverse tan of 3. Put it into your calculator and you get an angle of 71.6 degrees. So that's how you would find that angle that line makes with the positive direction of the x-axis. Okay, so that's an example for the only new thing. There will be some questions that will be revision of National 5 involving the gradient as well. So can we have a wee look at exercise 1A? And we have a selection of questions that are given here. And as always, ask your teacher for help and send in a photo of your marked work. Okay, good luck and take care.